All right, so we're going to continue solving some linear equations, but we're going to add in another layer. If you feel like following a process and knowing what to do next is a little bit of a struggle, you might want to create an index card like this that has all the steps on it. And this one, by the way, I have larger for a reason, because this is the one where if kids are fresh at this skill, this is where they make a mistake. So if you think you'd like to make an index card like this and you don't have one, just ask me for one and I'll get you one that you could create. You could keep it in your folder and then get it out to follow as far as how to go through solving an equation. So you can go ahead, pause this if you need to copy it, and then go ahead and put this second assignment on your tracker. And what we're going to layer in today now is how to solve equations when you have a variable on both sides. So what we've been doing so far is isolating that variable on one side of the equation, undoing all of the operations that happen to the variable so that we can see what the variable was originally. So we're going to still do that, but with variables on both sides. So for this first part, you need to do it, but I'll leave this up to you. You need to, based on your knowledge from our first day together on equations, is find out where did the mistake happen in solving this. So find the mistake and then go ahead and see if you can finish doing this one correctly. So you can do that now and pause the video, or you could do it later, but don't forget to do it. Okay, so if we follow the steps on the guidelines there, the first thing we would do is distribute if we have parentheses. So number one here, we don't have any parentheses. So the next step would be to combine any like terms. So they'd have to be on the same side. So on the left side, I don't have any like terms, and the right side, I don't have any. So we always want to check these, do these in order if we have distributing or if we have like terms on either side. We want to clean all that up first. All right. So then the third step, and in this problem we're already to the third step, we need to get variables on one side. So it doesn't matter if you move them to the left or to the right, it really doesn't matter. If I wanted, but we still have to use inverse operations to move things from one side to the other. So if I wanted to move this d here, I'd have to, it's a positive d, so I'd have to minus d. D minus d would be gone, but I have to do the same thing to this side, and then I'd get negative 7d equals 4. You can keep that there if you'd like. Another option would be to move the one on the left side. I could add 60 instead, and then that would be gone. Add 60. Now what you have to be careful of if you do this is you cannot write 7d equals 4. The equals doesn't go here, so you can't do that. This would be 7d plus 4 over here. Equal sign is here. So if you end up canceling everything on one side, you need to write a 0. And then we'd have to move this minus 4 over. And so then we'd end up with negative 4 equals 7d. And if you remember what you had a minute ago, what you had negative 7d equals 4. Either way, you're going to end up with the same result because we have to divide to get this d by itself. So I'll divide by 7, divide by 7. So d is going to equal negative 4 sevenths. So the solution set is negative 4 sevenths. If I did this one, I'd be dividing by negative 7, and I'd still get, so a positive divided by a negative is always a negative. We don't leave the negative down in the denominator. We would call it negative 4 sevenths. So either way works. All right, let's take a look at number 2. So step 1 is distribute. So we've got to distribute our 2. So we'd have 2c. 2 times negative 6 is negative 12. Remember, when you're distributing, use this sign with the number instead of bringing down a minus. You don't want to use it as a minus and a negative. You can do either one, but if you use it as a sign, like negative 6, then you'll be a little less confused. 2 times negative 6, negative 12. Okay. Now, There's no like terms on the left side, no like terms on the right side. So we're ready for step 3. Get variables on one side. So a rule of thumb, it's not mandatory, but if you want to deal with a little bit less negatives, then you want to move the smaller one. But like in this case over here on number 1, I moved D, and -6 is actually smaller than D, but in the original one, when I did it this way, I moved the D because I thought that was easier. So it doesn't really matter. So in this case, if you want to just get in the habit of doing it the same way every time, because you get confused easily about where things are, just always move stuff to the left. And that'll help you when we get to inequalities too. So if you want to move the 2 because it's smaller, go ahead. If you want to always bring things to the left, let's move the 9c. So we'll minus 9c minus 9c. So you can see what we're going to create here. 2 minus 9 is going to give us a -7. All right, so we'll have to deal with it. This comes down, minus 12 equals 2. All right, so now we're just isolating the variable like we've been doing. So we'll get rid of minus 12 by adding 12 to both sides. I keep the wall here just to know where my equal sign is. So I have -7c equals 14. And then lastly, I'll have to divide by -7. So c is going to equal a positive divided by a negative, -2. So that solution set will be -2. All right. Now, let's see here. Make a little space. For number 3, here's my equal sign. So I could move the 3m over, but then I'm going to end up with nothing on this right side. So I'm going to go ahead and move the m. If you need to, write it. Remember, that's an invisible 1m. So to get rid of a whole 1m, we're going to minus 1m to both sides. So if it's positive and you want to move it to the other side, you have to use the opposite. So we'll bring down -5, and we'll have 3 minus 1 gives us 2m. So last step is to divide by 2 to get rid of multiplication. So m equals -5/2. That doesn't divide, so we'll keep it as a fraction. No problem. Okay, on number 4, now I'm going to remind you, if this is just going a little fast and you need to pause it to kind of soak things in or read back through it, you do that. You go at the pace that's going to make you successful. So we'll check for distributing, but we don't have parentheses. We'll look for any like terms on the left. I don't see any. None on the right. All right, so we're ready to get our variable on one side. So if we want to go, I'm just going to move the smaller one, -3x. I just think it's a little easier to do than minusing 40. Either way would work. You'll end up with the same answer. So 40 equals 40, and then 40x minus 3x will give us positive 37x. Then I'll have to minus 40 from both sides. Now I'll have 37x equals, and this is going to make 0. So when I divide by 37, 37 goes into 0 times. So x equals 0. Remember, 0 is a solution. Some kids want to call that no solution, but that's different. We'll learn about no solutions a little bit later. Okay, so step 1 is always distribute if we have parentheses. So we'll have 5 times -5, or -25n. And then we have 5 times +7, so that's positive 35. Bring this stuff down. Look for like terms, none on the left, none on the right. So then I can move my variable to whichever side I want. So I'll bring it to the left this time. So to get rid of -5n, I will add 5n. If we're going to the opposite side of the equation, we have to do inverse operations. So adding 5n here. Now you got a picture. If I have 0 all the way up to -25, and I'm going to add 5, adding is this direction, so I'm going to end up at -20n equals 15. And now I have to isolate that variable. So I'll get rid of the adding by subtracting. Negative 20n equals 15 minus 35 is going to give me negative 20. Now you definitely, please, I'm begging you, don't write stuff down just because I did. Calculate things yourself and make sure you understand why and how they're coming out the way they are. So dividing to get n by itself, and then we get n equals positive 1. All right. Let's see, number 6, no distributing, no like terms on either side. So we'll go ahead and get our variables on one side. I could minus n if I wanted to, minus n. So I could have also added 2n to that side, and then I would have ended up with positive n's. In this case, negative 2, which would be right here, negative 2, and I'm minusing another 1. Remember, that's a 1. So I'll end up with negative 3n equals negative 14. Now I have to subtract 7. So negative 3n, if I have negative 14 over here and I minus 7 more, I'm going to get negative 21. Dividing both sides by a negative, so negative divided by negative makes positive. And 21 divided by 3 is 7. So we've got 7 for our solution set. Okay. Number 7 also doesn't have distributing, and it also does not have like terms on the left or on the right. So we can move our variable to one side. I'm going to move the 2. 2 is a little smaller, so oops. I'll minus 2 d from both sides. That one's gone. 3 minus 2 gives me just 1d. Be careful about this sign here. Make sure it comes down negative 7. When I minus 8, picture that number line. If I'm at minus 8 and I'm going to, oops, I'm at minus 7, sorry, minus 7, and I'm going to minus 8 more, I'll get to negative 15. So d equals negative 15, and that one's done. Not so bad. Okay. Now I can see I'm going to have some like terms on number 8, so let's see what happens. So first is always to distribute. 3 times t is 3t. 3 times positive 4 is 12. And then bring down minus t. And bring down this side. Okay, now I have no like terms on the left, but on the right side I have like terms. So when you're doing like terms, this is where things can get a little fishy when you're working with variables on both sides. If they're on the same side, we don't do inverse operations. We just do what it says. So we've got 3 minus 1. That will give us 2t. We just do what it says on that side. No inverse operations. We just combine them. 3t minus t. Bring everything else down. Now we're on step 3, get variables on one side. So now we have to move either the 2t or the 6t. I'm going to move the 2. But if we're moving it to a different side, we have to use inverse operations. So minus 2t makes it go away. So 6 minus 2 will give us 4t, and that equals 12, and then we have to divide, so t equals 3. All right, we get to distribute 2 fractions. Awesome. So remember, top goes to top. Top goes to the whole number. Bottom will go underneath. If there's nothing underneath for it to multiply by, it'll just be the only thing there. So 1 times 2f will be 2f over 2. And then 1 times negative 6 will be negative 6, and that also goes over 2. We'll do the same thing here. 1 times 8f will be 8f, and that needs to go over 4 because of this guy. And then 1 times 16 is positive 16, and that needs to go over 4. Okay, so what we'll do before we look at like terms or anything is see if we can clear out our fractions. So we're lucky on this one, they actually divide. 2 divided by 2 is just 1. So we have f. Negative 6 divided by 2 is negative 3. and then 8 divided by 4 is 2f, and 16 divided by 4 is positive 4. All right, now we're ready to look for like terms. Don't see any on the left, don't see any on the right. Okay, now we got to move our variables to one side. So we could move the 2f to this side, minus 2f, and we'll get negative 1. Or we could minus a single f from this side and get positive 1. I'm going to go ahead and move things to the left. Even though this is going to create a negative, I'm tough. I can handle it. You can do it either way. We should end up with the same answer. So 1, if you want the invisible 1, you can do it. 1 minus 2 is going to give us negative 1f minus 3 equals 4. Now we got to add 3 to isolate this variable. Negative 1f equals 7. Negative 1f is not finished yet, so we have to divide by negative 1. So we'll end up with f equals negative 7. Okay, let's see if we can apply this here. One health club charges $44 sign-up fee and $30 a month. So we'll call this health club 1. Another health club, we'll call this 2, charges $99 sign-up fee and $25 per month. Okay, so club 1 is $44 to sign up plus $30 per month. And we'll say M stands for months. Club 2 charges $99 to sign up plus $25 a month. And they want to know what number of months, in other words M, is the cost the same. Same means equal. So we can make these two things equal to each other. This one, and then we can solve for M and find out how many months it was. So when will club 1, 44 plus 3M, equal club 2, which is 99 plus 25M? That should have been an M. So this is called, when it's very similar. Well, I'm not going to confuse you. Anyway, all right, when the two things are equal. So we got to get our variables on one side. So I'm going to minus 25M. Okay, so we have 44. 30 minus 25 is 5M. Equals 99. And then we'll minus 44 to start isolating that variable. And we'll get 5M equals 55. When we divide by 5, we'll get M equals 11. So 11 months. So we'll say at 11 months, the two clubs, the two clubs, costs are equal. The two clubs' cost. Or the easier way to do that might have been, at 11 months, the costs of the two clubs are equal. Be a easier way to say that. So there you go. Now, if you just kind of filled this whole thing in with me, what might be good is if you tried it by yourself. So if you weren't trying to pause things and work a little ahead of me, and you'd like to try it by yourself, you could ask me for a blank copy. Or there's a blank copy on JT Learn that you could pull up, and then there's a key there. Well, you could use yours for a key now. So you have a key, and you can also come back to this video either way. Just make sure you understand, and then give yourself a smiley face if it's complete and you understand. Good work!